Problem 1. For 0 less than or equal to t less than or equal to 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t equals 2 sine e of t over 4 plus 1. The acceleration of the particle is given by a of t equals 1/2 e to the t over 4 cosine e to the t over 4, and x of 0 equals 2. All right, for part A, it says, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. Well, we learned that speed of a particle is increasing if acceleration and velocity are the same sign, and it will be decreasing if acceleration and velocity are different signs. So we pretty much need to find the velocity and acceleration. So we're going to find the velocity at time equals 5.5, which means we're going to go into our velocity equation, and we are going to plug in 5.5 for the t. And when we do that, we will get negative 0.453. All right, and then we'll find the acceleration at 5.5. And when we do that, we'll plug 5.5 into the t. So we'll get 5.5 over 4 cosine e to the 5.5 over 4. This might be the trick, just typing that into your calculator. When you do that, you'll get negative 1.359. And since the velocity and acceleration are both the same sign, we know that speed is increasing. So I will say speed is increasing because v of 5.5 and a of 5.5 are the same sign. Alrighty, that was worth 2 points. If you were able to say that the speed was increasing, you got a point, and then if you were able to explain why, you got a second point. All right, for part B, it says to find the average velocity of the particle for the time period 0 to 6. All right, average of anything is 1 over b minus a times the integral from a to b of your function. In this case, our function is the average velocity, so that's what I'm going to put here. So we'll have 1 over 6 minus 0 times the integral from 0 to 6 of the velocity. All right, and we can either write it like that, or we can write it, we can actually put the velocity formula in there. They don't mind which one you use. And in each case, I really should put dt. And then when we do that, we will get 1.949. Right, this was worth 2 points. We got 1 point for the integral setup, so you had to have every single part of this correct, and then 1 point for the correct answer. So that part was worth 2 altogether. All right, part C, find the total distance traveled by the particle from t equals 0 to t equals 6. Well, we know that the total distance traveled is the absolute value of the velocity, so that's what I'm going to be setting up here. We'll go from 0 to 6. The absolute value of velocity, again, was 2 sine of e of t over 4 plus 1. And then when we do that, we will get 12.57. We've got 1 point for the integral, so if you have this 100% set up correctly, that was worth a point, and then if you have the answer, that was worth a point. So this part was worth 2 points total. All right, part D. For time equals 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. I kind of see two different things happening in here. I've got my particle changing the direction, and then I need to find the position. So we will tackle both of those, and we should get some points for either one that we tackle. All right, first of all, if the particle is going to change direction, the velocity will change to positive to negative, which means at some point the velocity would have to equal 0. So I know that I need to set the velocity equal to 0. And when I do that, I'll have 2 sine e to the t over 4 plus 1 equals 0. And since I get to use my calculator, I am going to make use of the 0 feature of my calculator. And when I do that, I'm going to get t equals 5.196. All right, so we found where the particle changes direction. It's at 5.196. And then it said to find the position of the particle at that time. Well, first of all, we need to find the position. You'll notice that the position is not given. We only know the velocity. And we do know we're going to be taking the integral. We're going to have 2 sine of e to the t over 4 plus 1 dt. My only problem is this: if I go to you do this without my calculator, I'm going to get stuck because I'm going to do a u substitution and du is not there. So we're going to use our calculator. I am going to use 0, and not instead of 0 to 6, I'll just go 0 to 5.196. All right, so when we do that, we're going to let our calculator do the work right there. When we do that, we will get 12.135. When we did that, we found out how much the particle moved from 0 to 5.196. So if I want to know where the particle is now, I need to figure out where did the particle start at. Well, we know up here the particle started at 2. So I'm going to add 2 to that answer. So now the particle was at 2. It moved 12.135 units, and we are now at 14.135. So that's my final answer. All right, so points on this one. We'll get 3 points. If you considered the velocity equaling 0, we're going to get a point. All right, the second point we are going to get is if we have this integral set up exactly how I have it set up, we are going to get a point. And then if you got the final answer of 14.135, you got an extra point. So that entire thing was worth 3 points. So once again, please put a score out of 9 up at the top of your paper and circle it.